Hello viewers, welcome to my YouTube channel, Technician Kelvin. As you can see, I have got plenty of AVRs here that I want to show you something about the AVRs. You can subscribe to this YouTube channel for more informative talks and experiences. So these AVRs, they come in different shapes, sizes, but the shape does not affect the operation of the AVR. So what I want to show you today is the design of the AVR and the parts and the components, how they operate, and how they keep your generator producing power. So here we are going to check the mount type ones and the square ones. As you can see, this is a 3 kilowatt AVR, a square one, and here I have another bigger one with no ratings. But according to my understanding, this is a 7 kilowatt AVR, and here I have a 5 kilowatt AVR with no ratings too. But through experience, I can affirm that this is a 5 kilowatt AVR for the single phase generator. So these AVRs, as you can see, there are plenty and they come in different sizes, as I have told you. When you are replacing an AVR, make sure that the ratings on top of the AVR are the same as the parts as the original one you removed from the generator. So this is a 250 volt 470 UF AVR, and this is a 250 volt 470 UF AVR. So let's say this was the original one that was on the generator. If you remove this one, then this part is replaceable with this one here, because they have got the same readings, and meaning they have the same size. So these are these are spare for the other, they are compatible. But as you can see, this one, as much as they look alike, but the ratings on this 450 volt 680 UF, these are very big AVR, meaning it can run a three-phase generator, which here we normally use 415 for three-phase and 220 for single phase. So this is a three-phase AVR. As you can see, it has got a bigger capacitor with 680 UF. That's a microfarads. So on this AVR, let me use this one because it has not been interfered. On this AVR, you can see the two wires. These are the wires that are fed on the slip rings, which are connected through the brush. This is the negative one and the positive one. At times, people interchange during connection. When you interchange these ones, you have interchanged the polarity of the armature. So it means that for you to generate voltage, the generator must go in the opposite direction, which is very hard to change the direction of the generator to go in the opposite direction. So that's why you need to be very careful on connecting these. This is supposed to be in the inner side of the generator of the brush, and this is supposed to be on the outer side. Uh, Here we have got four wires. The blue ones, they are for excitation purpose, and the yellow ones are for voltage sensing, so that the AVR can continue getting the voltage from the excitation coil which is in the generator, and it continue generating the voltage. Here we have the AC voltage is always fed into the AVR. It is converted into DC for excitation purposes, because you can't excite an amateur with an AC voltage. An AC voltage has got no polarity, so it will be very hard to generate an electromagnet with an AC voltage. Uh, on the AVR, when you look closer, you can see this blue part, the blue material. This blue material has got a very tiny screw. This tiny screw is always used for voltage adjustment. Some operate anti-clockwise. When you turn clockwise, the voltage increases. When you turn anti-clockwise, the voltage drops. This is a heat sink. It is used to absorb the heat generated by the circuit inside here. That's why you can see an integrated circuit here that dumps the heat to the heat sink. The semiconductor is used to to prevent the lag the during operation and voltage loss during charging of the capacitor. So that is what you all need to know about the single phase AVR. Continue subscribing to my YouTube channel so that you can continue getting the best out of it. Thank you.